Hi folks, and welcome to this explainer of 10 multiple choices questions all about uncertainties, percentage uncertainties, combining uncertainties, etc. We're going to try and take 10 minutes on these 10 questions. If you'd like to try the questions before you do so, I suggest you look at the link which is in the it can be found at the bottom of the video. Let's get going. All right, so the first one is we have got an equation of omega equal to 2 pi divided by t, where t is a period, and we're given the value of t and also its percentage uncertainty. Doesn't matter if you don't know this equation, all we have to do is use our uncertainty rules here. And it's actually very simple because in this case, 2 and pi are known quantities. There's no uncertainty there. So really what we've got is a very unique situation whereby the uncertainty in omega is equal to the uncertainty in t. It's the only variable that we have there, and so therefore their percentage uncertainties must match. And so therefore, actually, you're told the answer in the question, delta omega over omega is just 5%, because that matches with the percentage uncertainty in the time variable as well. So a nice simple start to go with. Let's see what the next one is. We're now measuring the radius of a circular plate. We've got r and we've got delta r, and we're asked what the fractional uncertainty in the area of the plate is. Remember, fractional and percentage uncertainties are really interchangeable terms. We know that area is pi r squared, and again, area is going to have an uncertainty, but pi itself does not. So really, the uncertainty in the percentage uncertainty is just going to be the same as the percentage uncertainty in r squared. Now you should be aware that to get the percentage uncertainty in r squared, all we have to do is double the percentage uncertainty in r. And that's why the answer here is A. Remember, we're using the fact that pi is a known quantity, it has no uncertainty, and so therefore we're going to use our rules about combining uncertainties in order to work out that the percentage uncertainty in A is the same as the percentage uncertainty in r squared, which is double the percentage uncertainty in r. Oh, we can just miss the top of this one, but don't worry, the question's there. We've got a quantity now which is x equal to 2 times lambda times y divided by z. And again, we don't know what these things are, but it doesn't matter. We want to know the percentage uncertainty in x. Well, we are multiplying and dividing here. And so therefore the percentage uncertainty in x is the sum of the percentage uncertainties in the other quantities. Delta lambda over lambda, y over y, and z over z. All we have to do there is add them together. We've got 10 plus 0.05, and then we've got a 5 there as well. The answer here is going to be approximately 15%, because obviously we're going to ignore that 0.05% given the fact that it's much smaller than the other numbers we're using. So the answer here is B. The length of the side of a cube is 2 centimeters plus minus 4%. We know the mass and its percentage uncertainty. What is the percentage uncertainty of the density? Well, we know firstly that density is mass divided by volume, which is mass divided by L cubed when we're dealing with a cube, because all the sides are the same. Therefore, the percentage uncertainty in the density is equal to the sum of the percentage uncertainties in the volume and the mass, remembering that when we have a cube, then all we have to do is triple the percentage uncertainty in the cubed value. So our delta L cubed becomes 3 times delta L divided by L, which means we've got 8% plus 3 times 4%, which is going to be 20%. We've got now a radius of a sphere with absolute uncertainty delta r. Again, this is looking similar to our question about the area of a circle. Well, V is 4 over 3 pi r cubed. Here I'm using large r. We could use small r as well. Delta V is just going to be the percentage uncertainty are going to match up there. Percentage uncertainty in V is just the percentage uncertainty in r cubed, because 4, 3, and pi are known numbers. So r is the only one which contributes to my uncertainty. And as we've just said, if we take a value to the power of n, the percentage uncertainty of a to the n is just going to be n times the percentage uncertainty in a. And so therefore, in this case, we've got r cubed. All we have to do is triple our percentage uncertainty in r, which means our answer here is B. Horrible one, this one. We've got a relationship k equal to the square root of a over x, or a max over x0. A handy thing to do here is to remember what square root is. That is the power of a half. So we're going to apply our same rule here, which is the idea of powers, is that if we have n as our power, all we have to do is stick that n down in front of the percentage uncertainty of the original value. So in this case, percentage uncertainty of a max multiplied by a half, because n is 1/2 here. And we do the same for x0. We add them together, and we're left with a half of 12, which is somewhere up at the top here. A half of 12 plus a half of 20 is 6 plus 10 is 16%. Really nasty question, this one here, and it's a really good test of your understanding of how we take the percentage uncertainty in powers. Hopefully a slightly nicer one. We've got sides of a square, and we know that we're measuring them 5 plus minus 0.2, 5.0 I should say, plus minus 0.2. We know that the area is just L squared, which is 5 squared, which is going to give me 25. I'm keeping the significant figures here at 2. Delta A over A is just going to be 2 times delta L over L, again using our power rule, which is 2 times 0.2 divided by 5, it gives me 0.08. If I then multiply that, and multiply that by the value of A itself, I end up with a value of 2 for my uncertainty, which means my answer here is C, 25 plus minus 2. We have another question about cubes here. Okay, we know that the volume is L cubed, and therefore we can take our value of L and cube it, we get 1000. Again, I'm trying to keep the significant figures here, although it's difficult to tell with a number like this. We then need to think about our uncertainty. Well, again, V is L cubed, and so therefore delta V over V is going to be 3 times delta L over L. We know the percentage uncertainty in L, and so we find that we have a value of 0.09 for my percentage uncertainty in V. And therefore, what I need to do to get delta V is multiply V by its percentage uncertainty to get 90. The answer here then, therefore, being D. 2 more to go, folks. Okay, slightly horrible looking one, but actually fine. We've got a relationship for G, and we need to work out its percentage uncertainty. We know the percentage uncertainty in T and in L. We'll notice here we're multiplying and we're dividing here, sorry, and so therefore we're going to add together percentage uncertainties. We need to double the percentage uncertainty in T because it has been squared. Okay, so we will take those numbers. We'll take 2 times 5, which is 10, plus 2 gives me 12%, which is D. Last one here, folks, is to look at our uncertainty in the absolute uncertainty in the volume of a sugar cube. And again, we're going to use the fact this is a cube. V is L cubed. We're doing 10 cubed, which is 1000. Okay, I'm missing some units there. The percentage uncertainty in V, again, gives triple the percentage uncertainty in L because we are cubing. So therefore, we've got 3 times our uncertainty, 2 millimeters divided by 10, which is 10 millimeters, and so therefore we get 0.6. That's actually a pretty huge percentage uncertainty there. We're 60% uncertainty. All we have to do then is multiply our value of V by the percentage uncertainty in V. We get 600, and that leaves me with an answer of 1000 plus minus 600 millimeters cubed. D again. Now I realize that is super quick. I suggest that you go slowly through this. The key rule that we're practicing here is the power rule, whereby if I'm, for example, cubing something, then if I want to find the percentage uncertainty in V, I multiply the percentage uncertainty in L by 3. If I'm squaring it, I multiply by 2. And if I'm taking it to the power of a half, or I'm square rooting it, I am taking it to the power, I am multiplying it by a half. Get practicing those rules. Get trying that, and you'll feel a lot more confident with this. Any questions, please let me know.